Hopefully some of our colleagues will come in from the coffee break. But if the session participants would like to come to the stage. Da 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 da. Hello. Okay. Sorry, of course. Hello. Sound check, mic check. All right. Well, can we have the music go down? All right. Well, welcome back from the coffee break. I hope everyone had a good break and enjoyed some of the lovely sweets that we are able to have here. Okay, jumping back into our schedule, our next session is water and land focused, and we have Amos Kaboba as our moderator. So Amos, the floor is yours.
Hello, everyone. Hello. We are talking about water and land here. Hello, everyone. Because, thank you. Yeah, I think this is a follow-up to the action because we just finished a section on agriculture and now we are coming to zero in on water and land sustainability. So I have our distinguished panelists here. So at least they are going to give us some highlights about what they are doing. I'm reminded about the time, 7 minutes, 8 minutes. So I think that this section is very important. And please bear with me if at a certain point I call your name, because we are all on water and land and we all have some ideas, because it is very, very important that we all contribute, because in general, in all of these things, what we are thinking about is that for the ODOC and for the Geo Knowledge Hub, at the end of the day, we need to see how we can plug in all these different elements in order for us to make the needed impact that we need. So without much ado, I will call on our first speaker, Ipe from the FAO, to give your talk. Thank you.
Yes. It's gone. Okay. I'll wait for my presentation. Yes, there we are. And well, my presentation is now under land and water sustainability, but actually it could have been also in the earlier session on agriculture, because what I'm going to talk about is mainly on monitoring land and water productivity by remote sensing. We have developed for that a system which is called the VAPOR system, and VAPOR stands for Water Productivity Assessment by the use of open source data through remote sensing. So let's first start with a bit about the constitution of FAO, and that is the first article of the constitution of FAO is about collecting data and giving information to its members. So we have very big information systems for that. FAOStat is one of them, and Aquastat is another one, and Aquastat is the one that I'm showing over here. And the VAPOR system sits under the Aquastat as information system. Aquastat started as a statistical system with basically a whole set of variables, but with one value per variable per country. And of course, that's good for reporting and for comparing one country with another, but it is not useful for farmers. So if we monitor water use in agriculture, in space and time, that is extremely difficult. It's more difficult than monitoring land use, because land does not change, in the sense that it is, if you put an area around a plot, the plot remains the same. But the water use is different because water flows. So sometimes there's more water available and sometimes there is less water available. And to know how much water is being used in agriculture, then we use this type of gauging stations. And yeah, then you have one value per point. But that's not what you really want, because you want what you want. If you want to change the management, then you need much more data points over a larger area. And there, remote sensing can help. So what we have done is developing a system of remote sensing, remotely sensed data, and that you see over here. The Vapor project that contains this system that started in 2015, and first we started with Africa and the Near East. But since 2 years, we have now the data available globally, and the data that we provide is on water productivity, actual evapotranspiration, reference evapotranspiration, precipitation, and also now relative root zone soil moisture, which is new. In the first version of Vapor for Africa and the Near East, we did not have that data. Currently, that particular set of data is in the beta version because we are still testing it out, and we are asking the users also for feedback. Furthermore, we have information on net primary production, of which we use for yield estimations also, and a whole set of quality layers, which tells you a little bit on how reliable the data is and on which data, on which time series the data points are based on. So we have the system is available in 3 levels. The global level, which has a resolution of 300 meters. We have a level on 100-meter resolution that is for Africa and the Near East and several countries for which we have some focus areas. And I don't know if you can see that. Yes, you can see that. Those are the dots, and on those dots we have data available. On 20 meters, so that is very, very high resolution, and then it becomes also interesting for farmers. The system is set up as follows. So we have the database, and the database, as I just explained. Then on top of that, we have a program on capacity development on how to use the data, and on top of that, we get to the applications, the actionable applications, and we discussed that also in the earlier session, because that's basically what you want. You want that people are using the data, and what was said earlier by the gentleman over there, that you need farmers are not interested in data; they are interested in knowledge. So that is the point where we try to get from the data to the knowledge. Here you see the differences in resolution. So the global data is 300 meters, 100 meters for the continent of Africa and the Near East, and some countries, and then you have the subnational areas as on the right hand side. Everything is being set up in such a way that it is accessible for everybody, and it's actually evapotranspiration. that comes every 10 days. We have a new data layer with also a delay of more or less, well, a maximum 10 days. So the next one. This is Pakistan, for which we have data on the 100 meter, and then this is the field level data that we provide. And here you can see, and I think yes, there it goes, that you can the near real time data shows. This is on soil moisture, that you see over there the coming up of the central pivot irrigation system, which you will not see on the map below it, which is a static map from Bing. Since we're talking about open data and open knowledge, for us the knowledge sharing is extremely important. We have all the data is openly available. The data comes from free satellites. We have everything well documented in wikis. The models are open source. The APIs are open and described, and we also have a PyWaper package for which we can that people can use to have to find out more how the system works exactly, and also making their own adaptation to their to the model if they're not happy with the results, and if they want to do some tests with other concepts. These are the users that we are aiming. So we are getting to the policymakers. They are using the system. Irrigation scheme managers we are getting to, but the most difficult part again is, and that has been discussed several times, those are the farmers, and that is where we still have to put more effort in to get them also. And that's something that I hear all the time over here also. So this is something that really needs to, that's where we have to move indeed from the data to the knowledge and to the actionable information for farmers. That's about it. You see over here the URL for the website, and also the email address if you want to have more information. Many thanks.
Thank you. Thank you very much for your nice presentation. I think just wait a bit, because as he was talking, I was thinking in my head, because we have so many platforms, so many initiatives. And I quite remember when the Geo Knowledge Hub was launched, we were all excited. And we all mentioned that we were going to find a way to plug in and make our platforms discoverable. So I just want your comment. How can FAO, with this nice idea, how can you plug into the Geo Knowledge Hub? It's already part. Great. If it is already part, that is excellent. So we clap for you for that. Which also means, while it is part, maybe they will need to get some additional resources to build capacity, so that outreach, we can be able to get to know more about it. Thank you very much. On that note, I now call on, we want to talk about the Geo Mountains, James, to talk on the Geo Mountains. Thank you very much.
Okay, so good morning, everybody. Thank you very much for being here. This presentation will look at mapping the hazard posed by geological mass movements, such as landslides, debris flows, rockfalls, which are of course inherent to mountainous terrain. And we'll do this using Google Earth Engine, which perhaps surprisingly doesn't seem to have featured so much during some of the other presentations this week. So this is of course being conducted, one of several activities under Geo Mountains, and it particularly relates to this second aim of ours, to integrate and apply existing data and information for scientific policy and practical impact. We're working under the Adaptation at Altitude program, focusing in particular on 5 key developing or less developed mountain regions. These are complex regions where in many cases the number of people and therefore the exposure is growing rapidly. Often there is no existing hazard mapping, and therefore we need an efficient method to derive broad-scale hazard and therefore eventually risk estimates that capture the local details to the greatest extent possible. These events are of course very locally, very spatialized locally, and this is therefore a data-driven approach which exploits existing open data and also this accessible computation system, Google Earth Engine. However, before diving into some of these other regions around the world, we wanted to develop some workflow or methodology in a location where we have good data already. And so we chose the European Alps to start off with, and we took a landslide catalogue which was compiled and published almost a decade ago now by a researcher at the University of Exeter in the UK. So we see, for example, there are many events in this catalogue in France and Switzerland, but actually for some reason there are not so many in Austria and in other countries. And therefore we can consider this a little bit, this mapping exercise, as a little bit of an interpolation task to try to establish in these regions where we have historical events, are there some safer regions, perhaps what are the patterns like here, but then also can we translate our knowledge to the locations where we have fewer historical events. A real strength of Google Earth Engine is that we can very, very easily extract and start processing and working with large high-resolution data sets. And of course, we can also exploit quite considerable theoretical understanding of which factors or drivers influence landslide occurrence or mass movement occurrence. And so in this animation, I'm just showing very quickly some of the predictive variables which we considered: elevation, slope, this is slope, the position topographically, whether we're on a ridgeline or in a valley, and several other aspects, land cover, for example, the geological bedrock lithology. The location of roads can also be very important, so we can calculate the distance away from roads and use this as a predictor. Likewise, geological faults, and for example, some soil hydraulic properties such as the saturated conductivity, the propensity of different regions to experience extreme precipitation, and also variability in temperature. And here we're plotting on top, of course, those historical events. To derive a model using this fairly classical, simple machine learning approach, it's also necessary to generate so-called null samples. These are events which did not result in a landslide, if you like, or locations where we don't have landslides. This is to train the model to differentiate between the conditions under which landslides can occur compared with those which do not lead to landslides. So really by learning these relationships between the predictive variables, so these covariate layers which I presented, which are spatially continuous, and the outcome, whether or not a landslide has happened in that location in the past, we can then develop a model to predict this. And so in this first case, we used a fairly classical approach, as I mentioned, random forest, which can handle these non-linearities between the predictors and the target variable. We, of course, employed a standard approach for splitting up the training and testing data randomly, and we tested several different models, and also then, of course, evaluate the performance on this independent test data. And finally, we could then apply the resultant model in so-called probability mode to derive a probability map of landslide occurrence across the entire region. And so this can be interpreted, if you like, as the long-term landslide susceptibility at a given location. I won't spend too much time on this, but just to mention that for the training data set, we saw very, very good performance. Of course, these data are seen to the model, so this is not surprising. But in the independent evaluation, we again had 88% accuracy metric, which suggests that there's not too much drop-off there. There's not too much overfitting of this model. We can also look at the influence of the different covariates as well. But in the interest of time, I won't spend too much time on this. And there's several other things which we could also look at. for example, looking at the bivariate relationships and partial dependence plots and so forth. But I'll immediately show what this very, very first version of the map looks like. This was literally put together in maybe 2 or 3 days of work, so it's a very efficient process as well. And we can start to see some of these patterns. If we zoom in a little bit more detail, we can see that once this loads. And another nice feature of Google Earth Engine is that we can really also visualize the data in an extremely efficient fashion. We can turn layers on and off very easily. We can make them transparent. But we see here, for example, that the model seems to be doing quite a reasonable job in extrapolating, if you like, these areas of high susceptibility near known or historical landslide locations. So this seems very sensible. We can also zoom in slightly. Of course, I wouldn't necessarily recommend that we go down to the level of an individual house or so forth, but we can also see that, yeah, we're really picking out these areas as high susceptibility in red, of course, low susceptibility in green. This is the probability of landslide occurrence. Quite well, also in the region where I live, so I just chose this region for also where we work in Bern. However, it seems that there's still some work to do in Austria in particular, where we didn't have those samples in the training data set. The hazard levels are too low. We see this difference, this reduction in susceptibility as we head to the east, which doesn't seem like it's kind of coherent or what we would expect based on theoretical understanding. We would still expect also relatively similar hazard intensity levels there as in France and Switzerland, of course. And really this is associated with these fewer samples, and this is therefore kind of a spurious result. And really I think in hindsight, and what I will do next is restrict those null samples and not generate these null samples in this region, because they seem to be kind of biasing the model towards predicting lower hazard in these regions. So it's really a kind of imbalance, a spatial imbalance in the training data. And also this just reminds us at a fundamental level as well of the importance of the training data. There's a lot of hype about machine learning, deep learning, etc., but it's not really a golden bullet, if you like. Really the traditional principles of statistics and statistical modeling still apply. We have to make sure that our training data are good and not be blinded by the hype. So in terms of next steps, I would certainly hope to integrate a historical event in inventory in Austria. We could also consider this issue of potential event reporting biases in the past record. So maybe landslides are more likely to be reported if they occur near settlements or near roads, for example. This is something to consider. There's also perhaps some uncertainty in these locations of the events as well. So we could potentially sample to compensate for this or to explore this, and of course conduct then thorough evaluations against existing susceptibility maps. It could also be very nice to add a temporal element, because we know the date on which these historical landslides occurred. So in theory, we could extract also the precipitation, for example, in a certain number of days leading up to those events in those locations. And this could then actually enable us to generate a kind of continuous forecast of landslide probability. If we take information from weather forecasts plus the model, we could actually every day, for example, update a landslide susceptibility map. And this would be, of course, very useful and interesting for local communities and management authorities, because really this extreme precipitation is in many cases a trigger of these events, along with snow melt and things like this. And then, of course, the final component is to extend this methodology to other mountain hazards, potentially avalanches. We could take a similar approach, although we may have to first compile these historical event inventories. Of course, publish the code, data, and documentation, following very much the open science principles, open knowledge, which really underpins everything we do in GeoMountains, and finally apply the approach to generate novel and also hopefully useful data across these focal regions of our program for disaster risk reduction and climate change adaptation applications. So my very final slide, I would sort of conclude by saying that Google Earth Engine and also the community catalog, which provides actually a list of data sets which can very easily be ingested, represent very powerful tools and resources. We can efficiently access these so-called big data. We can also actually easily upload other data, integrate other data which may not be sitting in the platform already, but which we may have from other sources, so this is also attractive. We can, of course, compute do data processing and modeling very rapidly and efficiently because all the processing is done on the server side, and it's free for nonprofit and academic use. But of course, the data preparation stage, despite these advantages, and it's getting easier and easier, but the data preparation phase, the discovery, selection, and this feature engineering is still the most time-consuming aspect of the entire workflow. So things are getting faster, but this is still really the bulk of the effort is in the data side. And this could potentially in future help us to augment existing products which are relevant for policymakers and educators, such as the Mountains Uncovered series, which provides a fact booklet for 100 global mountain ranges. But in this first version, we have some gaps related to biodiversity, for example, related to natural hazard and risk, and we also need to improve these products in the future. So thank you very much.
Thank you very much for a nice presentation. Thank you very much. We need to value our mountains. We need to really value our mountains. Thank you very much for that presentation. Now we go to the next presenter, the wisdom in indigenous knowledge. I think this is very important. So Titus, please give us your presentation. Thank you.
Good morning, everybody, and thank you for giving me this opportunity. I think I will present the context of Samburu tribe, and more so on the pastoral life, having in mind that most communities in northern Kenya are pastoralists, and I'm sure one of us, also Mohammed, is highly affected on this. And some of the challenges that we are facing mostly on that, especially on water and land, are similar to all of us. And one big challenge is you'll find that the pastoral movement corridors are already closed. We no longer move from long distances from one point to another point. And also disconnection from water points. Historical water points. You'll find that a Samburu or a pastoralist can move even up to 300 or 400 kilometers in search of water and pasture. And again, the land, we consider most of the grassland being historical for the pastoralist. And those land already has been taken over either by development or cities or towns. And with that, or with those challenges, then the community need to start thinking on what to do. If you look at some of the traditional knowledges that we have, at the beginning you'll find that if the elders see birds or let's say wildlife moving toward a certain direction, or livestock behaving in a certain behavior, they know that possibly there is hope, there is rain in that particular direction. Birds, let's say moving northern and coming back with green grass, they know that there is rain somewhere, and they follow the direction of those birds. Sometimes even looking at the livestock far, the body of the livestock. Sometimes you find that they can even tell that drought is coming just by looking at the far. And looking at the stars, for example, traditionally every evening you'll find elders coming out, and sometimes even taking young men or young boys, so that maybe they train them and tell them the prediction or what the stars tell. But because of all these, then because of climate change, you'll find that all these are no longer happening, and this calls now for a sustainable land use, or maybe sustainable water use for communities within maybe their reach, because of those challenges. So some of the challenges that we face as pastoral communities include things like internet connectivity and access to key climate data. As you know that maybe even where we are, sometimes, and my colleagues in Africa can agree that there are some areas that even the government, they call them hard to reach areas, meaning that infrastructure and development is extremely poor on those areas. So if roads are not available, then even internet and other connectivity are not available. So accessing the data or climate data is a huge challenge. Lack of funding for indigenous-led projects, limited or lack of relevant government services within those areas. Where I come from, the program that we run we have mobile clinics and mobile schools. And you find that if somebody goes to a market or a shopping, the next day he comes or she comes, she doesn't find the village and the school. So they have to move looking for where they have already moved. Indigenous knowledge not taken seriously either by partners or governments. So those are the main challenges. And due to these challenges, as a community, we came up with solutions. And one of the solutions I mentioned yesterday is the Namunyak app, which is really assisting us to develop even the land use plan, because we know the land is already limited. The land is not growing, but the population is growing. So we initiated the Namunyak app. And if you look at that map, is one of the ways that we are using it to monitor wildlife movement, because land is shrinking and we have to share with wildlife so that maybe to reduce human-wildlife conflict. And elephants are collared just to ensure that we are able to know where they are, and so that the people will avoid where that is. And again, to reduce human conflict using camera traps. So as I mentioned yesterday, maybe for those who were there yesterday, the reason why we developed this is because we know we are not moving anywhere now. The corridors are completely closed. We have to manage the amount of land we have at that moment. So the Namunyak app will assist us to map out the land that we have. So that, and even do what we call land use planning within that. And we have already done an attempt to map out our boundaries and also to secure it from other development projects that maybe may come and shrink more the land we have. Again, also we use the same application to map out critical water points or areas maybe we need to locate new water points, because even sometimes if water is available throughout the land, then settlements will be everywhere. So again, we make sure that we don't put water points everywhere to encourage settlements. And also using the same application to do what we call grazing plans. Grazing plans means we put some grazing blocks. We have areas that we graze during the dry period. We have the areas that we graze during the wet period, just to ensure that the community has sufficient grass throughout the year. And also mapping out, or maybe mapping out the areas that we consider critical for wildlife or critical wildlife habitat. Also water catchment areas, we make sure that we map them out, and historical sites, just to ensure that the governments or maybe development agencies don't come and use the land without the knowledge of the community. And also we use our political leadership to push for the gazettement of these areas, so that it becomes gazetted and respected by law. Then again, the other thing that we are doing, we are raising a lot of awareness on the use of this app. We wanted even the county government of Samburu and our neighboring communities to have the same similar thing. So we want the county government of Samburu also to own the application, and that's why if you look at the logo, that is a map of Samburu land or Samburu county government. So they are already aware, and we want them to own the application also. So that maybe they will be using to secure the land, because 90% of the land is grassland and area, or maybe the community living there, 80% are pastoralist. And again, also training more the use of these to the women. So basically, this is just to address the challenges that we have, and mapping out the corridors, the wildlife corridors, mapping out the livestock corridors. And we have already also done the same with Kenya Wildlife Service, which is an agency mandated by the government to look after wildlife, to assist us also in mapping those corridors. And we are lucky because the elephant corridors are nearly the same as livestock corridors. So with that, I think that's all I have. Thank you. Shaoleng is thank you in Samburu.
Thank you very much. Thank you very much. This is really, it's just reminding us that we must remind ourselves that this planet is not only for us, it's also, we have the wildlife and we have to also plan for them because at least we have more wisdom than them, so we have to plan for them. Thank you very much. So, is it working? Oh, back. I think I was faster than it. So I am going to give a very brief talk, and I'm happy my colleagues are behind there, Sarah and Caesar. Thank you for helping me to put up this presentation. So if there are any gaps during the comment time, you can also add your input. But for a lot of you, you know me for Geo, AfriGeo, Digital, but I am the Dean for International Relations at the University of Energy and Natural Resources in Ghana. For those of you who don't know, because I think I am always misplaced with Oligio. All right. So today I want to just highlight some key things because I want to raise some questions a bit because in our development, we have theoretically put our planning and everything into two concepts. So for example, if you come from the country where you have all these nice story buildings, it means that you are developed, you are okay. If I come from the other side, you are not developed. So this is already creating a massive problem in our development agenda. And I, who comes from the northern part of Ghana, I will feel like, yes, I have to push hard to reach to this stage, which means whether there is wildlife, there is forest, there is anything, I want to push ahead in order to reach to this side. So, but if you look at our concept of sustainable development, it doesn't, when you read about it, it's not really the case because most of our building materials that we use for some of these, you can't really just recycle them. So I think our concept is an issue, and we love to be repackaging our issues. So now e-vehicles, yeah, we talk about e-vehicles, that is the way it's going to reduce the emissions. But we forget again that it's going to cost us on our lands because you have to mine more. We are going to do more mining. And what we don't talk about is where will the batteries go when they are spoiled? So the issue of One Health comes in here. Our survival issues come in here. So I think these are some questions that we need to be thinking about. Then it's always like, okay, we have a planet B somewhere. I don't know, NASA, ESA, and all the space agencies globally, I think you spend a lot of money trying to look for alternatives, but we are still not there yet. So it means somehow, because we do not have planet B, and we only have this one that we have, and the land is talking to us in different ways. We can hear from the landslides, we can hear about the extreme weather conditions, even in countries that they've developed, put all the drains, the flooding comes and it's still a problem. Even in Dubai, there was flooding. So it means there is something not right. And that is why within the GeoLDN, we feel that it is important we revisit our fundamentals about land and anything that is surrounding it, that we need to prioritize and we need to think about integrated land use planning. And I just love what my colleague said, that we have to plan with nature. We cannot be planning alone, thinking that only about ourselves. We have to plan with nature, with the wildlife, with the trees. Because after all, we breathe out carbon dioxide, we breathe in oxygen from the trees, and vice versa. So there's a need to have that connection in place. And that is why, at least with our technologies on EO, we can be able to better do some of these things. So just to highlight a few things from GeoLDN, we feel that, one, if you look at the map, somehow the geologists tell us that several years ago, million years ago, all the land was connected as one. And over time, because of tectonic and other activities, it's separated. Now, and somehow, when the land was created, it was one. It was one people, one land. Now we have several countries, and it's like every land is for one group of people, and this is creating the problem. So as a result, we had the first global dialogue forum where we brought together countries to sit together and talk and look at their challenges and see how they can learn from each other. What was very interesting is that when country A finds out that, I'm richer than country B and country B is doing more, they are encouraged to also do something about their land use planning. So I think this was one of the take notes from there. Now, out of that, and I'm happy Caesar is there. In fact, there are a lot of people sacrificing. Caesar is not sleeping. He's trying to help all these countries to really develop very specific use cases. And I think this is commendable. So these are some of the things that we are working on in GeoLDN. Now, the other thing is that, you see, there are important parts of the world that are still hosting a lot of good things that we need to, but sometimes the global maps, and one person commented, was it Kara, he mentioned that sometimes at the local level, farmer level, our data is not linking properly because of resolution issues. So we've been working to try to see for small island states how to reduce the resolution from FAO and others so that they can be able to see how it is relevant for them. So those are some of the things that as we are working towards our GeoKnowledge Hub to see how we can improve all of these things. Now, the other thing too is that I have said in other fora before, but I want to say it again. One of the things GeoLDN is pushing ahead is that we cannot be able to reach to all the ends of the world to promote our ideology. So we are looking at institutions that already have some capacity, so that based on that, we can be able to use them as help desks, so that the knowledge which is in GeoLDN could be transmitted to those regional help desks. And right now, RCMRD is one help desk that is helping us to reach out to the East Africa community, and now we are also exploring with CSC. I'm happy my good friend is here. So we are also, and just 2 weeks ago, we had a regional dialogue forum from several countries within the Francophone side. So these are some of the, and we are still exploring for Asia. We are still exploring for other regions. And this is a call, is late, but it's not late, because as long as it is mentioned here, it means that if there is still a chance, you can still apply and just give us a note, because we want to have also a regional dialogue forum just for the specific region. And I hope at this way somewhere listening. So there is still a chance to extend this call for those in this particular region. And I just want to thank all the wonderful people sacrificing in the back end. Sarah is here, Baron, and several others who are not here. Neil from Australia, for always because this is very important. We need people who are motivated. We have 4 working groups. Caesar is here. Please feel free to contact Sarah and Caesar for further details. And we are also grateful to our, let me call it, European Union in general, because the funding is coming through Germany, which means that it is also out of their collective effort. Thank you very much. And those of you from China, you can WeChat for any further details. And those of you from the rest, you can WhatsApp for any other details. So thank you very much for listening. Do I need to thank myself? Okay, no, I don't need to thank myself. Now, we go to the next and last speaker, but before that, we have good time. Before that, I want everybody in the audience to start to think about a comment or a question. You know, for us to solve our planetary crisis, time to come together like this is not easy. So take note of your comments. Soon after the last presenter, I will be coming to you. So I now call on Young Bo to come and talk on estimating current and future agriculture irrigation water use. Welcome, sir.
Okay. I'm sorry that Professor Wang can't be here because of something urgent. So he asked me to take over his presentation on his behalf. I'm Bo Yong from Chinese Academy of Science. The topic I'm going to report is about the estimation of irrigation water use in China using remote sensing. Irrigation is an important agricultural practice for maintaining crop growth and enhancing food production. Actually, it accounts for over 70% of the world's freshwater usage. However, the unreasonable irrigation is harmful. It can trigger a series of disasters, such as groundwater depletion and soil salinization. Therefore, the accurate estimation of irrigation is meaningful and crucial. Traditionally, the record of irrigation is heavily relied on the survey of Department of Agriculture. This method is generally the most reliable, but its shortcoming is also obvious. For example, time-consuming and laborious, and it's hard to coordinate, especially on large scale. In recent years, the development of remote sensing, it has been applied to retrieve various hydrological variables, such as precipitation and evapotranspiration. On this basis, remote sensing-based technology method has been deployed to estimate irrigation. Specifically, the change in soil moisture of cropland is caused by the water supply and the loss. Since the none variables in this equation are available from remote sensing, we can therefore deduce the irrigation. This method seems much simpler and faster. However, it's still half-baked because this is an equation in the ideal state, while the real water cycle is more complex. For example, the drainage is also a component of water balance, but the existing remote sensing technology is still unable to retrieve it effectively. So in this work, we took machine learning to estimate irrigation. Machine learning is a data-driven method which could establish the relationship between irrigation record and related variables from historical data. So we collect the record of irrigation from Chinese Ministry of Water Resource from 2003 to 2013. This data are provided on a city level and are specific on 3 crops: rice, wheat, and maize. Therefore, the output of our model will also take each city as basic unit. These are a part of remote sensing-based variables related to irrigation, which we refer to as features in machine learning. But notably, for some variables such as evapotranspiration, There are various remote sensing estimation methods and related products with their own shortcomings. So we take the average of this product to reduce the uncertainty. Okay, the next step is the selection of machine learning model. Until now, many models have been developed, such as reinforced support vector machine and artificial neural networks, which is very popular nowadays. In this work, we adopt Bayesian three-cornered hat method to integrate the output of these models. The mathematical principle of BDCH is a bit complex. Simply put, it is the weighted average of various models. Model with significantly different prediction from another model will receive a small weight. This is the validation of our method. We alternately select 1 year from 2003 to 2013 as test set, using the remainder as training set. The performance of our method is satisfactory, especially the Bayesian model, which achieves the most stable performance. But more importantly, this method could successfully reflect the trend of irrigation, which is very meaningful for the sustainable management of water resource. So now with this method, we can estimate the Croton irrigation. But a more challenging question is what it will be like in the future. This is quite important because in the past 4 decades, the global warming has intensified the evapotranspiration while the soil moisture is decreasing. This means the irrigation will be need more water resource, and perhaps we have to face more serious water shortage to fill the irrigation of need. Furthermore, according to the projection of Earth system models, this situation will continue in the future, and the demand of irrigation water will also continue. To quantify this demand, the environmental variables from Earth system models are input into the established machine learning model, and this figure shows the estimation result. We can find that the demand of irrigation water will continue to rise, especially on higher greenhouse gas emission scenarios. Compared to 2003 to 2013, the total demand of irrigation in China is expected to increase by 7 to 35% by the end of this century. If we convert this into the irrigation water transaction price, it will require an additional water transaction fee of $2.3 to $6.5 billion per year at the end of this century. Collectively, in this work, the feasibility of using machine learning and remote sensing to estimate irrigation has been demonstrated. In the future, the climate change will continue to increase the demand for irrigation, with a maximum possible increase of 35% by the end of this story. And moreover, it expects that the method can be extended to a global scale, especially in countries leaking monitoring and statistical data to provide assurance for agricultural production and global warming and climate change. Okay, that's all. Thank you.
Thank you very much. Is this working? Can you go to the next? I don't know. This one. Yeah. All right. Thank you very much for my panelists, how you have all discussed the issue. I know that Paula is looking at her time, but I just want to check, is there anyone who has a comment? I think you have. All right. Please, Mike.
I have a question and a comment which are completely independent. One question, could the help desk from the GeoLDN be a way to identify which are the topics of highest interest on which we could look for the knowledge we want to share in the Knowledge Hub.
Exactly, because right now we are thinking with GeoGLAM, because most of the use cases we are discussing in Africa are linking land degradation to agriculture.
Yeah.
So we are discussing with them to make the connection. Once we start that connection, it's possible that other things will come in. So I think this is one of the ways by which we could move forward. Yeah.
And then just a remark to follow up, it's for the indigenous populations. I think that the geo package standard from OGC could fit your need because it offers a format for the files, which is very light to onboard on a mobile phone, so a very small database, very efficient for geospatial information, and that can be completed when you have connection to the network. So it's also addressing poor networks connectivity. So we should follow that because in this case, I could work with Paola to see how we can make the GeoPackage standard more easily discoverable through the Knowledge Hub and all the resources that are already existing.
Thank you very much. Zaburu Foundation would like to make a comment on that? Or you just want to thank her?
Not really a comment, but say thank you, and that one will help.
All right. Any other comment? Yes, from behind.
Thank you
Okay,
very much. Thank you, Amos. I'm Sara Minelli from the UNCCD Secretariat. I just would like to say it's the first time I managed to finally attend the GEO event, and I've learned a lot. It's a very vibrant community. I'm happy to be part of it. Some of my takeaways from this participation and from this session, I feel there are a lot of untapped opportunity for collaboration. As GeoLDN, I think we would like to follow up with DigitalEarth Pacific to explore how they can help us fill gaps for reporting by small island developing states. We would like to work with DigitalEarth Africa because we are working with GeoLDN in some countries. We would like to work with GeoGLAM to see how we can bring crop-related information in our decision support system. So these are just some of the examples, and I hope we can follow in this session to see how to best work together. And on the help desk, indeed, we are looking at them as cross-cutting. So as a first entry point where countries, stakeholders could address their request for supports, demand, and then they would be directed to the initiative that can better respond to their needs. Thank you.
Thank you very much. I go to Carol, then I go to my friend there.
I would like thanks to report team because there were clear message about machine readable interface. I have only small question if there is also machine readable interface for catalog because it would make things more easy.
All right. I hope I might just take note of any things that you will need to comment. But at the same time, please, you are all encouraged. You see, there is this modern QR code there. Take a snap and make the survey. It's very, very important because it is through this we can be able to improve our way of networking and putting the actions in the right spot. Thank you. Now.
All right, thank you very much. I'll start on one of your very last comments about land degradation. And the thoughts are whether our conventional description or definition of land degradation with relationship to agriculture still stands uniquely as it had been from the beginning. This is because of the current context of the complexities around human insecurity, mining issues, especially around the Sahel region. The arid regions and the semi-arid regions of West Africa particularly are under this spell. And so degradation may not only be linked to weather indexed information or weather indexed events, and agriculture alone, but then we need to begin to also see the securitization of the concept itself and how it is impacting. I come from Nigeria. Several communities, farming communities, have been sacked by context, it's not communal conflict, but rather banditry, a lot of insecurity across several of these communities. And one wonders if our data on agricultural production has captured the implications of some of this, and also what may be happening by reason of a lot of we describe this, and how can we be able to motivate or elevate open data, data integrity, data relevance, data needs for such landscapes? Thank you.
Thank you very much. Sarah, would you like a 1 second, because you are the mandatory institution responsible for telling us what is the right definition of land degradation in the context of our economic growth?
Yeah, luckily not me in person, but yes, my organization has been discussing this definition for 30 years. So not an easy topic, absolutely, but the official definition, the one that all 196 country parties to the UNCCD has adopted, refer to land degradation as the reduction of the economic and biophysical productivity of the land. We came up with a system to report on land degradation globally that is intended to just give us an indication of where land degradation is happening. But land degradation is a contextual issue. We cannot have a system or a global data set that maps it at the global scale. We need to then go further down at the national level, at the local level, identify the drivers behind degradation, and define solution to address the specific problem there.
All right, thank you very much. And just to also add that hopefully in December, the UNCCD COP16 may come out with new dimensions of how we address this issue going forward. Thank you very much. To my panelists, I think I would just like each of you one bold message according to your heart, so that then we can close. So starting with GP, one message from you. You have the mic, please.
Well, that's extremely difficult, but because there are so many messages and they all are in a context. Sorry? But one, yeah, well, to me, it is a very simple message, and it's maybe not that bold, but you can't manage what you can't measure. So it remains important to measure and assess the water use and land use to see the sustainability of our planet.
Thank you very much. You must measure to know. James, please.
Thank you. I mean, given mountains cover maybe a quarter of the global land surface, they should not be neglected, generally speaking. And if we're thinking about these risks and natural hazards, of course, they could also be augmented by climate change. But I mean, where we're lacking data, even on the current state or the baseline, it's really important that we deliver this data to serve local communities. But it's very, very difficult because we have this extremely complex topography. These events are stochastic, if you like. They're difficult to predict in time and space. Therefore, we need to provide some indicative information, at least first order estimate, ideally also with some uncertainty information, so that people can consider the information and the uncertainty and take appropriate action.
Thank you.
And on my side, basically is on degradation at the pastoral context. You'll find that degradation is coming, or maybe it's becoming rampant because of livestock staying longer in one particular point. instead of moving from one point to another as they used to be. So taking long and overgrazing, causing such kind of degradation. So I think it's also something that need to be taken seriously. And as I mentioned, there's need for grazing plants because of the land is not growing. So a lot of attention also need to be taken on that. I know it's part of agriculture, but again, you know, mostly people focus on crop for getting livestock, especially on pastoral land.
Okay, 2 sentences. I'm glad to be here, and I'm glad to meet you all. I have learned a lot from this. Thank you all.
Thank you very much. And yes, so on his point, we have learned a lot. We have learned that we must measure to know, to understand that our mountains are still the source of our foods, lifestyles, food chain, and what have you, and even sometimes recreation. And we must also understand that the water budgets are critical, landslide issues are critical for us. And at the end of the day, we must also realize that land degradation is a critical issue, but we must redefine what is land degradation in order for us to understand the context in which we are operating and how we can sustain our wealth for a better future for our children, where we are all investing our time and effort and resources. On that note, thank you everybody for listening, and thank you panelists. Thank you so much. And I hope Paul Aldrin did not extend the time. We are good on time. Excellent. All right. Thank you very much.